All right, guys, here we go. You guys have been doing a great job for me this second semester. I don't need you to pack it in with one left here, 1 unit left. All right, especially this is units over 5 days of new stuff, and then the other 5 are practice. So we're going to be doing a lot of graphing. All right, a lot of graphing. And just to give you a little heads up here, we're not going to be on your XY axis anymore. We're going to be on a new type of graph that looks like this, okay, called the polar graph. And once you guys get good at this, at the end, the goal is to have you guys do some graphs that look like a circle. Some look like hearts, some upside down hearts. You'll see some different figures. 4-leaf clovers we're going to end up graphing. All right, but we got to get good at graphing on here before I give you those. All right, so first thing I want to do is just go review some stuff before the Regents exam. All right, review some stuff, and that is how to graph an angle on the XY axis before I show you this new graph. All right, so remember it went 0. What do we got up here? 90, it's just like riding a bike, right? 180, 270, and if you go backwards, it's negative. Remember, all right? So if I want to graph 145, what quadrant am I in here? So I'm graphing 145, quadrant 2. And remember how to graph these angles. First ray is on the x-axis, always on the positive side. And then make sure I always said be in the ballpark. All right, I'm not looking for exactness, but be in the ballpark. So 145, closer to 90 or 180? Buck 80, so just make sure you're closer to 180. And then anybody remember what else it's missing right now? My arrow telling me which way I'm going, which is, if it's positive, we go counter clockwise, okay? All right, so negative 30. Now we're going clockwise. So we'll be in the 4th quadrant, closer to 0 or 90. Closer to 0, graph it like that for me. And now just make sure your rotational arrow is going clockwise to show that it's negative and not on the other direction. All right, one more in degrees, and then I'll flip it on you. 295. 4th quadrant, all right. 270 or 360? Which one's closer to? 270, all right. Make sure it's in the ballpark, closer to 270. Good little review here. And then we go to number 4, which is not in degrees. What do we call that? That's in, look at you guys learning something this year. Radians, good. I'll make this quick on you. All right, usually I'd give your formula sheet out and say, do this, but remember pi is the same thing as 180 degrees. So you can just substitute in 180 every time we see a pi. So I'm asking you to graph negative 150 degrees. All right, just substitute in a 180 for the pi. And I didn't learn this, not that you care at this point in the year, but I learned this after we took the Regents, that your calculator can convert degrees to radians, radians to degrees for you. But it's not necessary right now anyway. Negative 150, where are we at here? Quadrant 3, closer to the 90 or the 180 there? All right, so make sure we're right there. And our arrow's going clockwise again. And let's go 13 pi over 8. Let's finish this review off good. 292.5 degrees. And that puts us in quadrant 4, closer to where? 270. Great job, guys. Great job. And now we're going counterclockwise. All right, good pickup. Good review there. Good pickup. All right, now we're done with these now. We're going to go on the new grid called the polar grid and do this. Why are we going on this first is I always told you, hey, be in the ballpark. Well, we ain't in the ballpark anymore. We're going exact now. All right, when we go to these polar grids, we're just not going to put it in the ballpark. We're going to go exactly a certain amount of degrees and radians. So the first thing I want to introduce you to is the grid and how we're going to label it. What's it go by? All right. I don't know if you guys see it or not, but your XY grid is already in here. You see it? Take a look. Your XY grid is already there. It's there already. I don't need, if you want to put that in, that's fine, but it's already there. So I need you to do a little senior level math here for me. Count how many of these tick marks there are all the way around and see what I'm going to go by. How many degrees is going to be each marking there? Okay, if you go all the way around, there's so many of them. And when you go all the way around, how many degrees are you going? When you go all the way around, how many degrees? 360. So you guys can work with those two numbers, how many markings there are, and you're going 360. Richie? We're going 15 degrees every time. All right, that's pretty exact. All right, so every time, take a look, everyone. Every time I go here, it's 15. 30, I'm not going to go all the way around. 45, 60, 75, and then, hey, look at that. Look where we are. 90 degrees. Great how that works. And if I go in clockwise, negative 15, negative 30, etc. All right? I don't need you to label it. If you want, you can, but we're going by 15s. All good. Everyone all right?
Is it the same for every... Oh, wait.
Every polar grid goes by 15 degrees. Okay. Now we'll do radians here now. Okay, you can just cross it off and put radians. All right, everyone ready? Because this is where probably we're going to work the most. What's it go by in radians? So basically, what's 15 degrees in radians? So maybe this is a good time if you guys are going to keep using your NumWorks calculator to do this. What 15 degrees is in radians? What mode are you in right now? I know, you check. I don't know. What mode are you in?
Degrees.
Everybody's in degrees?
Yeah.
Okay, so I want to figure out what 15 degrees is in radians. So go to your calculation screen. And I wish I knew this before we took the regions, but it is what it is. You type in 15. All right, how do I tell the calculator it's 15 degrees, right? We need that degree symbol. So you go where we usually go if we need anything. Toolbox. All right, keep scrolling down to, just want to make sure, units and constants. All right, units and constants. What do you think we need here? Length and angle, you got it. Length and angle. Which one do you think we want? Angle. Enter, and there's the degree there for you. Okay, so we can hit degree. Everyone see that one? All good? All right, we hit enter. Now, I hope mine's going to be different. Shoot, let me change my. I want to be in the same settings you guys are. Let me put mine in degrees too. All right, we're good. Go back to calculate. Sorry. All right, I'm still there. All right, so you hit enter, and it still says 15 degrees because your calculator's in degrees. That's why. But if you go up and highlight, everyone see the three dots over there that were usually, a little more info there for me. Hit enter, and it comes up. Tells you what it is in radians. Okay, so 15 degrees is pi over 12 radians. And again, I don't need you to do that for the rest of the unit. I'm just showing you that for college purposes. Here you go, 0. So now it's going to be pi over 12. And now you keep adding pi over 12 every time. So the next one's going to be 2 pi over 12. And I'll be honest with you, I don't really need it reduced. Okay, I don't need it reduced. And then we go 3 pi over 12. All right, all the way, we can just keep adding another pi over 12 on. And eventually you'll get to this one over here, which is 23 pi over 12, because you told me that there was 24 of these bad boys.
Wait, I have a question.
Go ahead, Paige, shoot.
If I, just did 180 divided by 15, 180 divided by 30, just put pi over whatever the number is, right?
Yes.
Okay.
All right, I just watch at the end of our notes today if that'll help you or not, though. Okay, because you'll see why I like everything out of 12. All right, everyone good? So I'm going to take those same angles we just worked with on the XY axes, And now let's graph them on the polar grid now. All right, we're going to graph them on the polar grid. All right, so first one, $1.05. Graph that on the polar grid, 105. Now, again, I'm not going to say be in the ballpark. You better be exact now because these things go by 15s. So first thing, I'm not going to change. Half of your angle is still on the positive side of the x-axis. Now find where 105 is. All right, my go-to is I know 90's up here, always. So instead of doing, you know what I'm saying, guys? Instead of doing 15, 15, 15 and figure out where 105 is, start with one of the axes there. So that's 90, and the next one's going to be 105, and that's all you got to do. Draw it right there. Now it's exact. We're not in the ballpark. That's exactly 105 degrees. The only thing that's missing still need it. Still need my arrow. So welcome to the polar grid, everybody. All right, where's negative 300 going to be now? Now we don't talk quadrant, we just talk exactness. Now remember, we're going clockwise now. All right, clockwise. And you guys can play around with the math too. Some of you might go, oh, that's negative 360. Go back 2. All right, go back. Oh, actually a little more than 2. Sorry, go back 4. All right, so you figure out where that other arrow has to be. Where is negative 300 on the polar grid? Negative 300. 1, 2, 3. I believe it's going to be right here.
Oh.
Guys, take a look here because this is the basics I need you to have down before we start graphing anything. Everyone all right? How I got negative 300 to be there? And then make sure, arrow, go in the negative direction, clockwise. Any issues I got to answer? All right, 240 before we hit radians up. 240. Let's see, that's 270. Go back 2 more right here. Okay, you guys okay on the 240 before I hit the radians up? Because I got to show you a trick here soon. All right, look at the radians now. 10 pi over 12. Now look, could you convert it into degrees? I guess you could. I want to keep doing that all the time. You know it goes by pi over 12 though, right? So you count 10 of them. We're done. Everyone see, we count 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's where it's going to be. It goes by pi over 12 every time. We just learned that. It went by pi over 12 every time. So just count 10 of them out, going in the correct direction. I'm not going to mark off if you convert it, but still, I don't think we need to convert it. Okay, and how I got 10 pi over 12. All right, now the next one, it's not out of 12. Maybe I should convert it. No, how about you make it out of 12? Right? Make it out of 12. What am I multiplying top and bottom by? This is why you guys belong here, and you can do this pre-calc stuff. All right, we don't need to convert it to degrees. Make it out of 12. So now I'm doing negative 18 pi over 12. Just make sure you know this is going clockwise, everybody. Going clockwise. And it should end up right there where 90 was positive. Kate. Okay. It goes by pi over 12 every time, right? Pi over 12, pi over 12, 2 pi over 12. So you want it out of 12 every time so you can just count. Right? Like this one up here. was 10 pi over 12. So all I did, do you see what I did? 1, 2, 3, 4, 5, all the way to 10. Right? Because it's out of pi over 12 every time. So if I can get it out of 12, I can just count like I did here. Now, where did I get the 6? That's what I got to multiply 2 by to get it into a denominator of 12. So 2 times 6 gives me the 12. 3 times 6 gives me that 18. So now I could just go count 18 around. Just make sure it's in the right direction because it's negative. Okay, good kick. All right, everyone else all right? Good question. Check your arrow on this one. Make sure you're going in the negative direction. Just check your arrow. And what's the deal with this last one here? What do I need to multiply by? 3, right? So now this turns into, actually, I want you to graph 21 pi over 12. Again, if it's out of 12, perfect. Now I can count. And just some tricks for some of you. Remember, if you don't want to count 21 around, this one right here at the beginning is 24. So you can count backwards 3 if you want as well. All right, when you go all the way around, there's 24 of them. Or go 21 if you feel more comfortable doing that. 1, 2, 3. Bless you. And there it is. Feel good there? Okay, welcome to the polar grid. We'll start graphing points Wednesday, Friday. Nope, Thursday. Tomorrow we'll practice, all right?